Good morning, good afternoon, or good evening. I'm Jackie Lynch with Flagship Solutions Group, and in this session we're going to cover the second half of our VIO server maintenance and care session. In this one we will cover backup and recovery and simple topics on monitoring. And specifically we'll talk also about storage in the network. So for backup and recovery, it's really important that you take backups of your VIO servers regularly. I'm finding that a lot of people are forgetting to do that. Whenever I make changes, I always use Alt disk copy, so I always have a second disk that I can copy to. That way, if I have a problem during my maintenance window, I can always set the boot list back to the untouched copy and reboot. But I also take a bootable makesysbe backup to a remote server or to some supported medium. These are the IBM supported backup and restore methods. You can back up to tape, to DVD RAM. You can back up to a remote file system that you can then use to restore from the HMC. You can back up with a makesysbe image to, for instance, a NIM server, or you can back up to a Tivoli storage server. The ironic thing is that you can back up and restore AIX from USB. You can install your VIO server from the USB stick, but you cannot back up and restore your VIO server from a USB stick at this point. Hopefully that will change in the future, but right now it is not a supported way to do a backup and restore. I have a backup script that I just put in crontab, and usually I have it running twice with slightly different names. So I run it on the 1st and the 15th of the month, or I run it once a month, and then I just run additional backups when I make any changes. You'll notice there's actually two backup IO lines. That's because the first line is the one that takes the backup for the HMC, so that if I have to do a restore from the HMC I can, and the second one is the one that full makesysbe that can be used from the NIM server to reinstall. I also make sure that I check my virtual backups because a makesysbe image will not restore my virtual definitions. So I use the VIOSBR command, and I run it once with this -file VIO backup frequency daily num file 7. What that does is it adds a crontab entry so that it takes a backup of all my metadata every day, and it keeps the last 7. And if you look at the other crontab entries, you'll see that I'm running two slightly different flavors of my backup script, one on the 1st and one on the 15th of the month. And the only difference between the two scripts is that they have different file names. Something else that was really interesting with HMC 950 is that HMC version now actually allows you to back up your VIO server configuration backup, so that's your metadata, to the HMC, and you can restore it from there. It also allows you to back up your HMC and store that backup on the HMC, and then later you can restore it. Just remember that your HMC only has about 15 gig allocated to the images, so you may not be able to back up very many copies, but in an emergency it could be very helpful. Also note that HMC 950 code requires a 7042 CR9 if you're using an Intel HMC or a new Power HMC. But once you get to version 9.2.951, it no longer supports the Intel HMCs. So this is the time for you to start thinking about migrating to the new Power HMCs. When you go to do an upgrade of your VIO server, the VIOS upgrade command will take a VIOSBR backup for you. But in general, what you may want to do is run a snap periodically so that you grab any critical data, and then I use NFS and I back up across NFS to my NIM server. So I'll mount it, and I always unmount the media library, because even though I tell it not to back up the media library, there seems to be a bug where sometimes it does and it makes my makesysbe huge. So I unmount it, run my backup, and then remount it. And as I mentioned, I actually do the two different types of backups. The first one where I just do the backup iOS file, and that creates that NIM resources tar file that can be used from the HMC. And then I also do the one that ends -makesysbe, where it actually takes a proper makesysbe image. And I do add the -no media lib flag, but I still unmount it prior to the backup. When you log in as padmin, you can't run scripts. So typically what we will do is we will do OEM set env and become root, and then we will run our script. So within that script, if you want to use the VIO-SBR command or anything like that, there is some flags you have to put around it. So typically in the script, you'll do an su-p admin-c, you'll stick the iOS CLI in front of it, and off you go. You can run VIO server commands. And you can see that I have a couple of different things going on here. I have the VIO-SBR backup, I have the makes this be, and then I have my NIM version. And if you use Alt disk copy to clone your root VG, you also get that extra fast failback. So I always do that as an additional pre-update backup to make sure that I have multiple ways to recover. So I normally start out by setting up my VIO-SBR. Once you've done it, you don't have to do it again. And I already mentioned I do the two different kinds of backups. I don't ever back up to DVD RAM or anything else because that's just too much like hard work, and I tend to lose DVDs, and I always have my NIM server. The 31125 backups that I was taking were around 19 gig, but during the backup, just before they compress everything, they could be as big as 40 gig. So I need to make sure that I have enough space in my backup directory to take two backups that could be at a given point in time, 80 or 90 gig, and then they will compress down to about 38. And again, the more junk you put in root VG, the bigger that backup will be. So try to keep a clean root VG. If you want to check your virtual backup, you can use the VIO-SBR-view-list command, or you can just do an ls on the directory that it was in. I like the ls because it gives me the date, the time, and the size, so I actually have a better idea of what's in there. I already talked about the fact that there's two different kinds of backups. If I'm looking at what the makes this be looks like that I took, that's a regular makes this be, you can see here it's about 19 gig, actually 18.10, and then the same version that I would use with install iOS from the HMC, you can see here that it's about 18.5 gig, same LPAR. I like to document my VIO information, so I have a script called save VIO stuff.shell. And I typically run that once a month or whenever I make changes, and it saves everything. Then when I run my backup, because it's in /home/padmin, it automatically gets backed up. So it's a good idea to sort of self-document as much as you can. And this is the output that it saves, which is just a bunch of different descriptions, like all my mappings, all of my adapter settings, my iOS level, all those kind of things. Now we're going to move on and we're going to talk a little bit about storage. And what I want you to understand is the two different kinds of PowerVM disk access. So the virtual SCSI model, which is what we started out with, basically the VIO server owns all of the disks, and then you map disk by disk, or we used to do logical volume, and that would show up as a disk in the client LPAR. But you have to keep track of those in massive spreadsheets and know where everything's going. Additionally, there are some limitations around virtual SCSI, and one of them is that you cannot use logical volumes if you want to use LPM. So just keep that in mind. And then we have import virtualization, or NPIV, which is the one that most of us are moving to now. And basically it treats the VIO server like a pass-through. The VIO server does not see the disks, it just passes through the fiber adapter, and the client LPAR sees the disks. So there's a couple of things that this impacts. The first thing is that if you are using different vendors' products, then for virtual SCSI, the MPIO drivers are actually in the VIO servers. Versus NPIV, the VIO servers don't have to run the MPIO drivers unless they're booting from SAN themselves, but the client LPARs have to run the MPIO drivers. Additionally, for NPIV, the switch has to be NPIV aware, because that switch has to have NPIV turned on those ports, or it can't use NPIV. And understanding the disk access is important for LPM, as well as for zoning and for LUN masking, which we'll talk about. So there's two terms that you need to understand with storage: zoning and mapping, which is also known as masking. Zoning is when you go to the switch and you tell the switch to let that switch port talk to the storage and the WWPN for the LPAR or server. Mapping or masking is when you go to the storage and you look at the LPAR definition and you tell it that these WWPNs can access these LUNs. So zoning's at the switch, mapping's at the disk storage. You have to provision the LUNs at the storage, map and zone them before they can be used in an LPAR. Now if you're direct attaching, for instance your VIO server is booting from SanDisk, then we actually zone and map the WWNs for the real adapters. For NPIV, we use the virtual ones that we create on the HMC when we create the profile of the client LPAR. The difference when you're looking at a WWN is that the real adapters tend to start with a 10 or a 20, and the virtual ones that NPIV is going to use typically start with a C0. If you run an HMC scanner report, you can find those. You can also log onto the LPAR or VIO or onto the HMC. Now from the VIO server you can actually check if the switch is NPIV enabled by running the lsn ports command. And that will tell you two things. Basically if it comes back with nothing, either the switch does not have NPIV turned on or they have not zoned your LPAR, they've not zoned anything for the VIO server to be able to see it. So you need to then check to make sure that the port's enabled and so on. It's important that you don't confuse zoning with mapping. They both have to be done. If you want to use LPM, it's important that you zone both the regular and LPM WWPNs. What do I mean by that? If you look at a profile for a client LPAR, and you go and pick any one of the fiber adapters, you'll see that there are actually two WWPNs, and they are consecutive. The first is the default one that is normally used, so when you boot the LPAR, that's what it will boot from. The second one is used by LPM, and it does not log in unless you've used LPM. So if I do an active LPM, the target system will actually use that second WWPN. If I then LPM again, it goes back to the primary one. So what that means is if you want to use LPM, you must zone and map both of those WWPNs, which means that the storage is going to show up as degraded because at all times half the WWPNs won't be active, and that irritates storage admins. Otherwise, if you do not do that, they can't use LPM. And if they're not mapped at the storage and you do an LPM, you can damage your boot image. So what I always tell people is the first time that you do an LPM, I recommend shutting down the LPAR, do an inactive LPM and then boot it, because if the masking or zoning isn't done right, it just won't boot. Versus with an active LPM, it will go across, but the first time you enter a command that is not cached, that's when you run the risk of corrupting your boot image. So just things to think about with LPM and storage. We also recommend that you keep your zoning very, very simple. A lot of people like to zone by fiber adapter port number, etc., etc. But from a VIO server, I can remap everything and now suddenly nothing matches. So I try to do it in a much simpler way. So this slide just talks a little more about the differences between VSCSI and NPIV. When you're using VSCSI, you're going to use the WN of the VIO server. So that's the one that's going to start with a 10. And you'll use that for zoning and also for mapping. All of the disks will show up at the VIO server and will then be mapped over to the various client LPARs. The NPIO drivers get installed in the VIO, and at the client LPAR you take the disk that's given to you by each VIO and you mirror them together. And all your fiber adapter tunables are set in the VIO server. If you want to look at them, you basically do an ls map minus all on the VIO and it will show you the various mappings for VSCSI. For NPIV, we're going to use the WWPNs that are created when we create the client LPAR profile. And those will migrate if you're doing LPM with the client LPAR. The disks are not seen at the VIO, so we install the NPIO drivers in the client LPAR. And we use the ls map minus all minus NPIV to see how those disks are done. In the case of tunables, we set the tunables on the fiber adapters in the VIO and we reboot them. And then we set the tunables on the client LPARs. And those client LPAR settings have to be less than or equal to the settings in the VIO servers after the VIO servers are rebooted. There have been a couple of storage arrays where we've also had to zone the real WWNs, but that's not something that you would normally want to do. So just keep that in mind. This is an example of a simple zoning for LPM. So here I've got a tape drive on each one, which is the 1 zeros and 2 zeros. The 5 zeros are the storage subsystem. But basically on switch 1, you'll notice that I have actually zoned the same WWPNs that I zoned on switch 2. Now, there's some reasons why you may do that and may not. It depends on your switches and your disk subsystems. But wherever possible, I just try to keep the zoning the same so that I don't end up in trouble if the mappings at the VIO server get switched around for some reason. You'll come up with whatever works for you, but just make sure that it's something that is very simple to debug when you're working with LPM, because LPM can be really tricky to figure out what's going on. Now, when you're using NPIV, you may need to log in the ports for an LPAR, and you can use the nport login command, and it will activate and log in any WWPs that it can. You can also do that from the HMC, in fact, and you could also use the LSN port login to find out what the status of things are. So here I went to the HMC and I basically went into the profile for my VIO server, for the client GPFS1, and I clicked on one of the fiber channel adapters and it gave me the WWPNs for that specific LPAR on VIO1. And then I did the same for that LPAR on a different adapter which came from VIO2. So you can see that there is a pair of WWPNs. And the first one is the regular one. The second one will be used the first time you LPM, and then it alternates between them. Now, if you want to check the status on the client, you can actually go into the client profile and you basically select any of the virtual fibers, actions, advanced, login, or log out fiber channels. So I can log them in and it will actually attempt to log them all in. That's what you do when you want to light them up for the storage admins, because most of the time they don't want to try to do any kind of zoning or anything if the virtual fibers aren't lit up. Then in terms of doing the actual mappings at the VIO server, you're basically going to use the VFC map command, and you're going to tell it what fiber adapter to map to which VFC host. And this is where it becomes a problem with zoning, because you need to know if they're going to do zoning by port and FCS, etc., then you need to know ahead of time exactly which port on which switch is which fiber adapter, so that when you do these VFC maps, you're mapping them in a way that exactly matches how they've set up the switches. So you're going to have a big spreadsheet. Now you can get this information using the lsdev commands and lsconfig commands on the VIO server. So this is showing me that I have FCS 0, 1, 2, and 3, and I have the network addresses here. Make a note that only 2 of these are actually real fiber adapters. FCS 0 and 1 are my 2-port fiber channel adapter. FCS 2 and 3 are actually the 10 gig portion of one of those fiber channel over Ethernet adapters, and I'm actually using those 2 10 gig ports for the network. So the only ones I really care about from a WWPN point of view are FCS 0 and 1. And you can see that FCS 0 and FCS 1 are P1C71 and P1C72. And that's the information that you may need to be able to provide to the person who's doing all the switch setup. I can then do an ls map -all -npiv, and I can grep a particular LPAR. It'll give me the VFC host name. I can then run an ls map against that specific host and see what's mapped to it, and so on. And I can also go look at my client and I can see what the fiber adapters are. And if you remember, on the previous one it was adapter 70 and 71 were FCS 0 and 1 on VIO1. So you could take these adapters. I have a strategy that I keep where I keep track of all these. So I know that 70, 71 are from VIO1, 90, 91 are from VIO2, and It's actually 180 and 181. Those are actually tape drives through NPIV. I keep all that in a spreadsheet, so I actually have it pre-planned exactly what's going where. I also look at my VSCSI mappings. Typically, I'm going to have a virtual optical, which is what this VTOP0 is, mapped to each of my LPARs. When you're using LPM, you need to remember to unmap those before you do the LPM. I already talked about this, but LPM uses both of the WWPNs that are in the profile. Normally when you boot, it uses the first one, and when you LPM, it will switch over to the second one when it gets to the new server, and that one will go live and the original one will be shut down. And each time you LPM, it goes back and forth between them, it flip-flops. However, if you do an inactive LPM, so you shut the LPAR down and then LPM it, it boots with whatever the worldwide port number was that it used last time, which tells you that you need to zone and map both WWPNs. Now, those 4-port 10 gig, 1 gig cards can be network cards or used for the SAN, and pretty much everyone uses them as network cards. And so you get all these FCS errors that are really irritating. What you can actually do is you can first of all find those cards, and then there is a way to actually tell it to stop acting as a fiber adapter. So here I find the cards, so I know that I'm talking about FCS2 and FCS3. Alright. As PAdmin, I can actually do these RMDevs and CHDevs, and now they will actually show up as defined, and the error messages that I was getting in my error log go away. If you ever want to actually use them as a fiber adapter port instead of as a network card, then you can basically do a CHDev and put them back to the way that they should be. I had mentioned HBA settings earlier, and we're going to talk about those a little bit. I normally tune my HBAs, and I don't tune them dramatically, but I do bump up the max transfer size, which is the IO direct memory access area, and my num command elements, which is basically queue depth for my fiber adapter. If you are using NPIV, the num command elements on your VIO must be at least as high as the largest setting on any client, and that VIO must be rebooted before the client is set to that value. And I have some links down here for some things where they changed stuff so that your clients could only be 256, and then they changed it back. So this is something that you probably will need to set. And depending on your disk subsystem, you're going to want to use 1024, 2048, or 4096. So you'll need to check what is supported by the disk subsystem that you're running. The max transfer size, as I mentioned, is your IO DMA. And by default, it's 16 megabytes. I always change it to 0x200000, which gets me 128 meg. Even though by default it shows as being set to the 16 meg, on operating system levels it uses 128 anyway, so I just change it to 128 so I know it's using what I expect it to use. So this is showing you what it looks like by default, and you can see you've got 200 queue entries, and on a busy VIO server you're going to need a lot more than that. So as I said, these are the changes that I quite often make. This is the command to actually make the change, and the -P is because that fiber adapter is in use. Then you're not going to be able to change it live. You'll have to change it and then do a reboot. So this is typically what my VIO server and NPIV client adapters are going to look like. Now NPIO has changed somewhat. IBM used to have you use SEA PCM for their storage. They've now switched to using AIX PCM. I'm not going to go into this in a great deal of detail, just to say that there is a best practices document you should look at, and there's also a number of articles on different things related to using AIX PCM. Additionally, if you're using systems where disks are being shared, which typically happens a lot, you need to make sure that you have everything changed to no reserve from single power. And in fact, I do that by default on all my AIX systems. You can actually set the system up, if your NPIO drivers have not, using the CHDev command to actually change the system so that whenever you add a disk, it actually sets the reserve policy correctly. And you can use the chadef-H command to check for any attributes that have been changed from the defaults. If you're at a reasonably recent version of AIX, you can also take advantage of the ls-npio command to get information about your disks. So here I do an lspv and check on HDisk1. Then I do an lsdev-C to see what kind of disk it is, and it's telling me that it's an NPIO IBM 2076. If I now do an lsnpio-QL on that disk, it actually tells me it's a 50 gig. It tells me what the group is that it belongs to on the storage subsystem. It tells me what the volume name is, and it tells me what the volume serial number is, all of which is very useful information. I can also check if the paths are optimized by running the lsnpio-L, so you can see that it's telling me whether or not they're optimized. And I can use the -ARE command to find out the parent for the H disk, and there's a bunch of other options that are also very useful. So this is the example of the -ARE. It gives me a lot of information for each path on what the WWPN is for each path, and on any errors, and how many it's had in total, how many in the last 10 minutes, and so on. So again, the lsnpio command is actually quite useful. The lspath command was actually updated to add a couple of new flags. The -T flag makes sure that the actual path ID is listed at the end, and the -I flag lets you specify the path ID and only get information for devices on a specific path. So if I do an lspath-L on HDisk1, it gives me all the paths for HDisk1. If I do an lspath-L-I-2, it only gives me path 2, which is FSCSI1, for HDisk1, and then I have the ability to say, okay, but show me everything that's on path 2, and it will show me all those HDisks. So just some interesting new path commands, and there's also some updates to make path and RM path that you might want to be aware of. Now, sometimes you'll find that you are missing paths, or you have failed paths. And that could be because you put a new adapter card in or anything. So periodically I run my little bad path script, which goes around and it looks for missing or failed paths, and it creates a remove path script. And this was based on a really nice article by David Tansley in IBM Systems magazine. And I have used this script with various flavors multiple times to clean up systems so I don't have missing or failed paths. Now your VIO servers on Power 9 and above can actually boot from NVMe. And so you can assign your NVMe devices to your VIO server partition, and you can actually boot from it. It's a high-speed flash storage, and it can be configured as local read cache for your shared storage pool, but you cannot use it in the storage pool. You can only use it as a local read cache. You can carve out logical volumes and assign them, but you cannot assign a whole physical volume on an NVMe to a client. So typically what I use NVMe devices for is my boot devices for my VIO servers, because you also can't use them in LPM operations or for active memory sharing. And if you are using NVMe for your VIO server boot device, please make sure that you mirror it. There's a bunch of information in the blog on NVMe support, as well as a section in the latest Power 9 technical overview and introduction red books. This is an example just showing you how all the NVMe drives connect in, and those diagrams came from that blog that I mentioned, so I highly recommend that you go and read the blog. Now we're going to touch on the network. So in the network, we basically take advantage of virtual Ethernet. And virtual Ethernet is simply the ability for two LPARs to talk to each other through the hypervisor on a virtual network adapter. We typically will do what we call link aggregation. So our VIO server will have one or more ports, and the second VIO server will have one or more ports, and we aggregate those together so that we get redundancy and so that we can get full bandwidth and less network traffic. Some people will use nib, which is the network backup. I don't like nib very much because I find it to be very pingy. So link aggregation is going to give you the ability to have a couple of different ports on each VIO that are basically aggregated together. Now there's a couple of ways you can do it. You can have each port on VIO1 go to a different switch, or you can have all of VIO1 go to one switch and all of VIO2 go to another switch. It really depends on the switches that you have and whether they will allow you to build a LACP aggregate across two switches. You need to pay attention to entitlement because virtual Ethernet performance scales by entitlement, not by virtual processors. The supplies in the VIO server as well as the clients. So that is something you do need to pay attention to. You do not want your LPARs or your VIO servers running above entitlement all the time. That is going to really hurt your network performance. If you have multiple VIO servers and you have two that are running the disk and two that are running the network, then on the network one you can disable network threading. And the reason for doing that is that it will improve your LAN performance. However, if you are running a mixed VIO server, which is what most of us do, then you need to leave that alone. You also want to look at turning on large send and receive. Those will actually help you with performance significantly. There's a couple of articles that I'm pointing to that are specific about how to use large send and receive on Linux and how to use it on IBM I. It used to be that you could not do that. Now there's, depending on the level that you're at, you should be able to do it. So again, you just want to check these two tiny URLs and see whether or not the level you're running has the issues resolved. As an example, most of the issues around IBM I and large receive were resolved in the base code for IBM I 7.2. Below that, there are specific patches that are required. Now, why am I talking about VIO Server 223 when we're up to version 3.1.2.21? The reason is that at version 223, there was a significant change to the shared Ethernet adapters. Prior to 223, you had to define an Ether channel if you were using it and an SEA, but for that SEA you also had to have a separate VLAN that was used for the control channel, and each SEA on that server would have to have a different VLAN for its control channel. As of version 223, that all changes. IBM reserved VLAN 4095 for all control channels. So when you build the SEA and you leave the control channel specification off, so you see here I've got the old and then the new, and you notice in the new I don't have control channel. It will automatically use VLAN 4095 for the control channel. Pay a lot of attention when you're building your SEAs that when you specify the priority, that you set it correctly, and so that one of them is 1 and one of them is 2. And don't mess that up, because otherwise when you activate both VIOs you can cause a spanning tree loop. So SEA setup has also been simplified. We no longer have a dedicated control channel and VLAN ID, but there's minimum levels that you need to be at for firmware, etc. Given that that came out multiple years ago, I would expect that you would be at a minimum well above these levels. So just remember, you don't have to define a control channel anymore. You can actually check your SEA and your control channel with the commands that I list on this page. So you list your Ethernets and you can see that my shared Ethernet adapter is ENT9. I can then do an ntstat and look for control channel, and here it's telling me that my PVID is 4095 and that the control channel has actually been assigned to the virtual adapter ENT4. So it just rides along on ENT4. And I can then check all my VLAN tags and so on. So the ntstat command is very useful when you're looking at shared Ethernet adapters and trying to figure out where your VLANs are, etc. When you're setting up switch ports for SEA failover, if you don't do it correctly, you can end up with failover delays, and I put a link in here to an IBM page that talks about that. So as an example, if you've got spanning tree turned on and you're using a Cisco, then you should have port fast turned on. For an IBM switch, the equivalent to port fast is spanning tree edge. So again, go and read that article and figure out if you're having problems when you're doing SEA failovers where you're getting delays, this could be the reason why. I highly recommend that if you're in a shared Ethernet adapter environment, that you actually test it. So there's a number of different ways you can test it. After I set up a VIO pair, I will typically log on to the primary through SSH, and I'll use the console to log on to the secondary, and I'll reboot the secondary and see if I lose my SSH connection. And then I will do that in reverse and see if I lose the SSH connection. If the switch ports are set up correctly and the SEA is defined correctly, I shouldn't run into any issues, but it's something that I like to check. I also check the ERRPT to make sure that the primary and secondary are failing over correctly, because there will be an ERRPT entry that says became primary or became backup. I normally force a manual failover when I'm doing maintenance by setting HA mode to standby on the primary, and while I'm doing that, I'm monitoring it on the secondary to make sure that it really does become the primary. You don't have to do that, but it is one of the things I do, particularly if I think the switch is not set up correctly and that my failover may be delayed. I've mentioned this in other presentations, but I have a starter set of tunables that I use for the network because they are not set by default. And by default, TCP send and receive are limited well below this 256K. So you set RFC 1323 to 1 and it allows you to use the whole 256. Now, UDP send and receive, you can't set UDP send greater than 65536, but by default it's way smaller than that. And you do have UDP traffic in your network because, as an example, your domain name servers use UDP. I mentioned earlier that network performance and throughput are dependent upon CPU power and that they scale by entitlement. There's a number of other things that can affect your network performance, and that includes the MTU size, your distance between receiver and sender, number of offloading features, firmware on your adapters and server, making sure that you have all the latest patches on for 10 gig issues. There's a couple of things I have listed here. There's a YouTube and a network performance presentation that go into this in a great deal more detail. Networking in a shared Ethernet adapter environment can become incredibly complex. The hypervisor itself provides an 8021Q virtual LAN style virtual Ethernet switch. You can have more than one of them. By default, you get Ethernet 0, but if you want to really segregate things out, you can add more virtual networks, more switches, bridges, VLANs. You can have internal or bridge networks. You can have no tagging. You can do 8021Q tagging. You can do load sharing, or you can just do failover. There's a lot of different things that you can do, so that's one of the things you need to do up front, is sit down and actually plan out how you want your network to look. And then you have the options of using SRIOV, which is specific to the card, and you can also take advantage of VNIC. So you want to have a look at the presentations on those and figure out which direction you're going to go and pick one that's going to work for you. I tend to do SEAs with SEA load sharing. I need to actually start doing some work on VNICs, but I haven't had time. What SEA load sharing allows you to do is have some of the VLANs be primary on VIO1 and backed up on VIO2, and the other VLANs primary on VIO2 and backed up on VIO1. So this way you can take full advantage of the bandwidth of the adapters. If you do a purely SEA failover with no load sharing, then what happens is VIO1, for instance, is the primary for all of the VLANs, and VIO2 only takes over when VIO1 goes down. So you may want to look into load sharing. And lastly, we're going to talk a little bit about monitoring. It's very important to keep an eye on your VIO servers. Remember that VIO server scales by entitlement, not virtual processors, so you have to pay attention to that. One of the signs you'll see of entitlement shortage is if you see a lot of virtual context switches. So you want to monitor those. If you're running close to your entitlement on average, then you want to increase your entitlement. So look at your percent idle though, because you can go over entitlement if you have too many VPs but not be using all the threads on the cores. So if you've got too many VPs, you may want to bump entitlement but reduce virtual processors. And if you're running very close to your virtual processors as well, then you're going to increase your entitlement and your virtual processors Some people even run their VIO servers dedicated. Under no circumstances should you ever let your VIO server page. That VIO server runs all of your client LPARs. If it's paging, everybody gets slowed down. You also need to clean up those VIO server page spaces. Remember, by default, the system seems to install 2 of them on the same disk. I usually delete paging 00 and I make HD6 bigger. And make sure that when you're sizing the system, that you actually plan for all the cores and memory for your VIO servers. I see many times that gets forgotten, and then all of a sudden somebody can't get the memory they want for their LPARs because they forgot that the VIO servers need memory, and they also forgot that the system has overhead for every LPAR because it has to produce those hypervisor page table entries. So make sure that you don't undersize those. I use nmon for most of my monitoring, and I run at 724. So if I want to do a quick 30-minute nmon, I'll run it with a 15-second interval, and I'll grab 120 of them, and I use all the flags. If you're running Workload Manager, then you'll also want to use the capital W flag. But I have a script that kicks off at 11:59 p.m. every night that basically runs a 24-hour nmon, which grabs a sample every 150 seconds. You can also run the Performance Advisor, which is known as PART, P-A-R-T, and that will give you some great reports on your shared Ethernet adapters. And on the HMC, if you're at a reasonably high level, you can also do what we call PCM monitoring. It gives you an overall view of the LPARs and VIO servers. So here I'm looking at my processor utilization trend, and it's showing me that, September 26th, my server utilization was about 7 cores or thereabouts, but it will actually let you know if the system is completely busy, and it does do auto updates. So here I'm looking at my network bridge and seeing what's going on there. So what's my network utilization trend? And again, these are very useful reports to get. Now, one of the things you're going to want to do is monitor the shared processor pool, particularly if you are taking advantage of shared processor pools where you've maybe isolated your Oracle or your DB2 to its own pool. In order to be able to get valid statistics, you need to turn on the Allow Performance Information Collection on the LPAR properties. It's a dynamic change, so you can just go into the LPAR properties and change it. Without that, you're not going to get cross-LPAR statistics. So, as an example, the available pool processors, or APP, will not be valid because it won't be able to report on what everybody else is using. You can use the Topaz-C, capital C command to get the reports. You can use nmon with the option P. You can look at nmon analyzer with the LPAR tab, and you can also use the LPAR stat command to get information on shared processor pools. So this is an example of the LPAR tab. So I can see for my VIO server, I was running happily below my entitlement. I had one little tiny spike, but there would be no need to change anything on this LPAR. Now you can get NPIV statistics. As of version 223, the Performance Advisor, or PART, actually supports NPIV aggregation information. There's also various flavors of the fcstat command that allow you to get information on the VIO servers, NPIV use, and there's actually, as padmin, you can use the fcstat-client. There's also a number of other flavors, as I said, of fcstat, and I've got the link down below to how to get those statistics. So this is using the fcstat-client on one of my VIOs. So you can see that it's telling me for VIO1 and AIX1 NIM, they're using FCS0, here's the WWPNs, and in requests, out requests, bytes, etc., and any errors that they had. So you can get that right from the VIO server. As I said, you can get SEA adapter statistics. I actually had to go and find this link because the adapter statistic report doesn't actually tell you what those statistics mean. So hopefully you'll find these useful in terms of what those actual numbers are about. Now, I use the netstat-v command to get information on my virtual Ethernet. And what I'm interested in is when I go down to my SEA, am I seeing drop packets and am I seeing no resource errors? If I am seeing drop packets and no resource errors, and hypervisor receive failures, that is typically a sign that I have run out of virtual buffers for my network. They don't have to be identical. The numbers in this case happen to be the same, but they don't have to be identical for you to have a problem. The key message is if you see all numbers in all three of those, then you need to go and check your virtual buffers on your VIO servers, and you're also probably going to want to go check them on the clients to see if it's all your clients that are having a problem or just the one. So if you scroll a little bit further down in that netstat, you're going to see some virtual trunk statistics, and you'll see min buffers, and max allocated. Now, the way this works is, because it's virtual Ethernet, there has to be buffers somewhere, so it creates them here. Those buffers will always have the minimum, and then whatever you set the maximum to is the most it can use. And max allocated, if it equals max buffers, will tell you that you've actually run out of those buffers. So I can see here that I ran out of small buffers. And so then I can actually increase my max buffer small to 4096. Unfortunately, it is one of those things that requires a reboot to change, but I at least have that ability. Now by default, IBM changed the buff mode to max min, and the problem with that is if you look in the little black box, you'll see that in all of them, min, max allocated, etc. are all identical. So the problem with that is you don't know if you're running out of buffers. So I typically change my buff mode back to min, and then I have a gap between my minimum and my maximum. Now, one of the reasons that they changed it was so that you weren't forever adding and shrinking and so on with the buffers. So you can make your minimum 3172 and your maximum 4096. And at least then, if you see max allocated going to 4096, you know that you're running out of those buffers. And that's the point at which you may end up deciding that you're going to split that shared Ethernet adapter or that virtual Ethernet or whatever into a couple of different ones so that you're not running out of buffers. Because if you're running out of buffers, all your network traffic will be delayed. I've mentioned the part command, and the part command is basically going to give you performance information on your VIO servers. So this is an example of running it for 30 minutes. Just run part minus I 30. You can also run part against the current nmon file, and it will produce a part report of that .nmon file. This is just some examples of the kind of output you see from parts. So it tells you, what kind of server it is, how many cores are online, what the VIO server level is. It gives you some disk information and network information. It then looks at all your VIO server disk adapters and your disk drives. And it goes into quite a bit of detail on the utilization, IOs per second. You can also click on all these little eyes and it will give you information about what it thinks about it. And same here for your CPU consumption, your processing modes, all of those things you can actually get more details on. And here it's got the information on the memory, so it's telling me I've got 3.88 gig page space free. It's telling me that I have 5.488 gigabytes, and it thinks I should have less than 4. And then I can actually click on this plus and get more information on the SEA. So I want to thank you for taking the time to listen to this session. I hope that you found it useful. Please don't hesitate to reach out if you have any questions. I have uploaded a copy of the presentation to my website, and it will also be available obviously through the PTechU site. I hope you enjoy the rest of the conference and have a great day. Thank you.